Welcome back to the channel. This is Anka Engineering and I'm Herman Wiegman. And today's video is to finish up the storyboard around clutches and flywheels. Hope you enjoy the content. Let's get into it. I just wanted to take a moment and talk about clutch bleeding techniques. The Jaguar F-Type does have a hydraulic clutch system, and there's a typical hydraulic reservoir and clutch pedal and some various cable ties, interlinks to bring you down to the slave at the transmission. Unfortunately, there are some dips along the way and some high spots, and there's also an intermediate bleeder point in the system that you can bleed half the system if you'd like. I found that to be interesting, but it wasn't necessary to use. I'm just going to introduce some concepts here, which is that of positive pressure systems like this power bleeder, which brings positive pressure to your reservoir and also forces fluid in and pushes air bubbles down and out through the slave. There's also a vacuum system. This particular product is an evacuator pump. It actually goes both ways. It can compress and send positive pressure, or it can evacuate and suck. I tried both at the same time, and these two systems typically apply 15 psi of either pressure or roughly 14 psi of vacuum. So when I was looking at the actual fluid in the hoses, they were actually moving quite slowly. 14-15 psi doesn't really push the fluid through the hoses very quickly at all. So in order to really move air bubbles through the system, I decided to go inside the car and depress the clutch pedal itself. And that gives you an instant shot of roughly 5 cc's of fluid. And of course it can also do it with great pressure. And that was very effective at getting air bubbles out of the system. While these two units by themselves would very slowly and gradually remove fluid, they didn't always pull the air bubbles out. So step on the pedal, give it a whole bunch of shots, and that should clear out the system in a hurry. In some previous videos, I've spoken about the various clutch options that I've been investigating for this car. And I'm just going to go over it real quickly. The original equipment from the manufacturer is a Sachs 250E pressure plate, which is one of these it's extended life. It's one of these self-adjusting pressure plates, and a simple friction disc. This one doesn't have any sprung center, and the reason being is because the flywheel is dual mass with torsion springs, and that takes out all of the pulsations such that the friction disc can be relatively solid like this. The only thing it has is a small damper plate to pick up some high frequency effects. So this is the OEM friction disc, OEM pressure plate, and the OEM flywheel. Now in this particular flywheel, if I flip it over, we can have a look, and the torsion springs are in here, and they're the elements that take up all of the torque pulsations or variations between the engine and the transmission, making it a very smooth and capable filtering device such that you always enjoy very smooth operation in the car. But of course these elements are problematic. The springs wear away, they break, and then you can have this dual mass flywheel system and can fail on you. And so to simplify that, I've commissioned a single mass flywheel, which by the way has all of the appropriate timing teeth and features and starter ring from an automatic transmission car's pressure plate, because those two are exactly the same in a manual or an automatic, the starter ring and the tone wheel for the V6. Okay. In this video, I'm going to give you how these two discs perform. This is the original disc that I put in the car with the single mass flywheel. This is a Sachs disc, 240 millimeter, but you'll notice that the springs are fairly tight and the amount of compression that they can accept is only just a few millimeters, probably on the order of 3 millimeters. So we know that this is a fairly highly sprung center disc, and those sprung elements are in there to reduce the impact on the spline shaft so that you don't ruin this friction disc and you don't transfer too much pulsation to the input shaft of the transmission, which I can mimic with the clutch tool here. Okay, so the experiment is whether this disc from ACT, which has much larger gaps, much more compression capability, to see if this has improved dampening capability such that the center spline receives even less torque pulsations than this application. So I did a quick driving test. Let's go take a look at those results and see how it fared compared to the original disc. Okay, with the clutch and flywheel installed, we're going to take the car for a spin, going up a steep hill close to my property. Starting out from 1000 RPM, fourth gear. Vibration 1250, and then it's kind of gone. By 1500 RPM, fourth gear is smooth up this hill. Let's turn around, do it again. Okay, we're going to go for fifth gear up this hill. We're going to lug it and see how it sounds. First into fifth. Starting out at low RPM. Through 1000, 1100, 1200. Full throttle. By 1300, it's gone. 14. 1500 RPM in fifth and you're smooth. Sixth gear at 1000 RPM. Sixth gear at 1000, 900. 900 RPM. 1000 RPM. 11. 1200 RPM. 1300 RPM in sixth gear and it's done smooth. 14. 15. This is a graphic that I put together actually 7 months ago when I originally installed the Sachs clutch and flywheel, or the single mass flywheel in the car. Now today's results are a little bit better, I thought, because I had a very steep hill where I could very zero in on the RPM and accelerate the car very slowly up the steep hill. Where previously I was on flat ground and I would be accelerating through the RPM range very quickly, and it was hard to take exact note of when the NVH, noise, vibration, and harshness, was occurring. So today's results are pretty good and I feel really confident about them. And you can see that sixth gear, there is a red zone where it really vibrates the car heavily, while fifth gear and fourth gear have reduced regions of harshness. And I hope that you appreciate seeing the data in this format. So this video is all about whether a loosely sprung clutch disc or friction disc could have an impact on reducing the vibrations that go from the engine to the back of the Jaguar F-Type. And it sounds like these particular friction discs don't have enough damping capability to remove that vibration. So with the single mass lightweight flywheel, there are some issues with lugging the car at very low RPM and having some noise, vibration, and harshness issues. Now for me, it's well worth it because you gain at the other end of the spectrum at the high RPM, 5,000, 6,000 RPM. Driving the car up there is really a joy now with the single mass lightweight flywheel. And the dual mass flywheel does give you that low RPM sort of smoothness, but unfortunately every time you shift at higher RPM you're waiting for ages for the engine RPM to come back down to engage your next shift. Well, that's not the case in the single mass lightweight flywheel. It's much more spirited and the engine's much more responsive, and you feel like you're wasting less energy on inertia. Hey, I also wanted to say thank you so much. The channel now has 14 or 15 subscribers. I think that's awesome. I originally thought that would be about the limit. How many people are truly interested in owning, operating, modifying the manual transmission V6 Jaguar F-Types? That's a pretty small esoteric crowd, but hopefully you all are finding some value in these videos. And hey, make some comments, give some feedback, and I'll get back to you on it. Appreciate it. And remember, drive well, my friends.